start to talk to you about where our food comes from and how persistence data mining has developed the patent-pending TerraSmart process in order to make farming more sustainable by increasing our yields, decreasing our inputs to protect our environment, as well as make farming more profitable for farmers. Currently, we've got a big global problem. We've got an increasing population, and what's happening is we're expecting more out of our land. As you can see here from this map, the countries in brown are countries using a lot of fertilizers. They're also producing a lot of food to feed their people. But one of the things that's happening is dead zones in our waterways, which means nutrient overload is going down through the waterways into our oceans and creating hypoxic zones. So one of our key elements is that we can help reduce that money that farmers are spending that's going down the drain and impacting the environment. Approximately 32% of a Midwest corn grower's inputs are caused by fertilizer inputs. So what the farmer's dilemma is soil sampling. Right now, farmers go out and they make a decision on 4 acres off of 1 cup of dirt. And this just isn't enough granular information. Now, as a 9th generation farmer and COO of persistence data mining, I can assure you that I do not want to flush away my money down the Mississippi because I put too much fertilizer on the ground. So what we've done is we've taken a labor-intensive process of soil nutrient sampling, where farmers actually go out into a field, they drive a stake in the ground, they bag it, they tag it, they ship it to a lab for chemical processing in order to determine what nutrients they need to grow next year's crop. Our system basically gets 40 times better resolution, faster and easier than traditional methods. So how we do that is we use a hyperspectral imaging sensor that we can take out in the field. It's less labor intensive, it provides more data, better data, and quicker data. So to give you an example, if you're not in the agricultural industry, a football field is approximately 1.1 acre. Right now we go out and every 4 acres we take 1 sample, that cup of dirt, and what it does is it produces a map that basically would have this as a solid color. Using hyperspectral imaging, we can get more data sets per acre, cheaper and faster. University of Nebraska research has proven that that would reduce input costs by approximately 15% while increasing yields by 13%. What this means to the average corn or soybean farmer is that last year in Illinois, farmers were estimated to lose $50 per acre because of input costs, and that didn't even take into account the low commodity prices that we're currently experiencing. Because of the increase in yields and the decrease in input costs, we can turn that negative $50 into a positive $50 per acre for the average corn grower in the U.S. This is basically a $5.1 billion precision ag industry that we're going after. Howsoever, there is 7.68 billion acres of agriculture on this planet. So a little bit about our technology. We use a hyperspectral imaging sensor to use physics instead of chemistry to map the nutrients directly in the soil. We go out, we scan the land, we connect to the cloud, we then process the information and get it back to the farmer. Again, easier, simpler, with more data sets per acre. Now this technology is not a new technology. We did not invent this technology. We have partnered with the sensor companies to strike special deals to work with the agronomic service providers that are already going out and providing these services, and they can provide a better service to their customers at a less expensive rate. Hyperspectral imaging is used by the Department of Defense. It's used by NASA. If you've ever looked up into the stars and wondered how they figured out what Jupiter was made of, well, they used a sensor in order to do that, and we're using that very same sensor. So basically, our core competency is the fact that we're able to reduce down huge amounts of data in a volatile system of the soil in order to pinpoint our exact nutrients. We do have an additional potential offering because we reduce for moisture, which can aid in irrigation eventually. We also reduce for soil texture, which can be used in making seed decisions, as well as the fact that our main focus right now is fertilizer inputs, but we can eventually go into those other areas. Our go-to-market strategy involves working with equipment manufacturers on both the spectroscopy side as well as the farm equipment side. Right now, we're working with Malvern Panalytics. We have preferred pricing deals. We're also working with John Deere. We have an API to integrate our information into their variable rate spreaders and sprayers. And we're working on a second pilot with Mahindra for global distribution of our technology. We're also working with soil laboratories. Right now, soil laboratories, with our minimal viable product that we're launching in the next 2 months, which is for organic matter. Basically, current practices involve a test called a loss on ignition. They charge a farmer $6.50 for this test. They put in about $5 to make a $1.50 profit. Basically, using our technology, we can reduce their costs substantially down below at $2. The current practice, if anybody knows anything about the lab, is they weigh the sample, they burn it at 500 degrees for 2 hours, and then they weigh it again to tell you how much organic matter is in your soil. If this doesn't sound like caveman technology, I don't know what does, but our high-tech technology will replace this quicker, easier, faster, enabling them to process more information. One of our goals for being here today was to partner with universities. We've already published with the International Society of Photonics and Optics, as well as the International Society of Precision Agriculture, and presented at their events. However, we are looking to also publish at the university level and partner with the universities to validate our research. As Dr. Ken Sedeth from the USDA ARS department from Missouri stated, this will create a complete paradigm shift in how we manage our land and grow our food in the future. Again, we've been working with public agencies. The USDA was nice enough to do a collaboration with us, as well as a well-known soil lab. So our progress to date is we've tested on basically 11 different states. We've tested on 2 different continents on 10 different soil textures. Soil textures play into the coefficients within our proprietary algorithms and our patent pending process. Our MVP is to work on 12 different states, 2 different continents, and of course our global reach is all 50 states, 5 continents, and 14 different soil textures. As I stated earlier, there are 7.68 billion acres, and in a lot of these places, people actually cannot grow the food that they need because they don't have sustainable practices, and the climate's impacting how much land they can grow their food on. So our financial projections are based on a subscription model. We'll be working with agronomic service providers to distribute our services for the back-end processing of the data that they go out and collect with their customers. We've got good buy-in from both the labs, the agronomic service providers, as well as the equipment manufacturers, and we think we'll be quite profitable here in year 3. We'll be deploying services again with the labs. Oddly enough, both the fertilizer companies and the labs are excited about our technology because there are restrictions being placed throughout the country regarding nutrient overload criteria. So basically, we benefit both our customer as well as their customer. Our executive team is made up of a number of visionaries. Myself, 9th generation farmer. My family originally settled in Illinois, and we've held on to that land ever since. Brian Zamudio and Henry Bonner have both worked on a number of startups, including agricultural products with international trade of cheese and tobacco companies. One of the stars of our team is Chris Totter, our CTO, that does all of our data reduction. We were lucky enough to get him after he finished his project on Deep Sea Challenger. He has a great ability to do big data analytics, which got our people down to the deepest depths of the ocean, and he was part of that team. Kim Fleming is well-published PhD in agronomy, who advises us on agronomic service level, as well as Warren Clark and Robert Latko, our VP of programming. As you can see, we have a number of development partners that we've been working with to create a network so we can distribute services and start generating revenues. We're looking to raise $500,000 so that we can move forward with our strategic partners and basically start distributing these services globally as soon as possible. Thank you.